What do you do if you run out of electrons before the central atom has an octet? So let's just use this example. So I'm going to just roughly add up the total number of electrons here. So carbon has 4, hydrogen has 1 valence electron, nitrogen has 5. So that's a total of 10 valence electrons. And if I count what I have here, I have 2, 4, 6, 8, 10. So this structure on the left already shows 10 valence electrons, but carbon only has 4, so it's not stable. It needs 4 more electrons. So what you do is you form multiple bonds. And so what I did was I moved these 2 lone pairs to form what's called a triple bond, which we'll talk about in more detail here. And so now I didn't draw any more electrons. I still have 10. So I have 2, 4, 6, 8. Remember, each dash is 2. So 8 bonded electrons, and then 9, 10. There's just 1 lone pair. So this diagram has the same number of electrons. They're just shared differently so that every atom is stable. So this carbon now has 2, 4, 6, 8. This nitrogen has these 6, and then 7, 8. And hydrogen, of course, is stable with these 2. Okay, so we're going to demonstrate how to do this in a future slide, but what we're going to do in the next couple of slides is just talk about what happens when these multiple bonds form. All right, so atoms form double and triple covalent bonds if they can attain a full energy shell by sharing 2 or 3 pairs of electrons. A bond that involves 2 shared pairs of electrons is called a double bond. And in a Lewis structure, we would see 2 dashes then, right? And a bond formed by sharing 3 pairs of electrons is a triple covalent bond. And we would see the 3 dashes there. So a double bond has a total of 4 electrons in it. And a triple bond has a total of 6 electrons in it. If you're viewing this online and you have access to the PDF, if you click here, it'll take you to an interactive activity on covalent bonding. What happens in terms of bond energy when multiple bonds are formed? So look what happens here. We have carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. So the more electrons we add here, what happens to the energy? It increases. Same thing happens with nitrogen. As we add more electrons, we share more electrons between the atoms, the energy increases. So it requires more energy to break double and triple bonds than it does to single bonds. So triple bonds are the strongest of the 3.